Hi everyone, I'm Henry. The project I'm presenting is titled Scene Recognition of Audiologically Relevant Environments for Hearing Aids using a Head DS and YAMNet Plus. Our work is a collaboration between Macquarie University Hearing Hub in Sydney, Australia and Google Research Australia. My colleagues who worked on this project are Jörg Buchholz, also from Macquarie University Hearing Hub, and Simon Carlisle and Richard Lyon from Google Research Australia. We introduced two key components in this project: a Head DS, a dataset for scene recognition, and YAMNet Plus, a sound recognition model. State-of-the-art hearing aids incorporate scene recognition in order to identify the audiological environment and apply appropriate processing such as filters, amplification, beamforming to improve a user's hearing experience. In order to perform this task, we need to develop a machine learning model for scene recognition. However, there are several challenges. There is a lack of open source machine learning models which can operate on low-powered edge devices. The model must work on edge devices in order to preserve privacy by avoiding the transmission of sensitive data and to minimize the cost of data transmission. However, not all models are immediately deployable to devices such as smartphones connected to hearing aids and wireless earphones. The other challenge is datasets are either not public, incomplete, or use labels which are not directly useful for scene recognition. They use different scene labels and are thus not directly comparable. We propose a two-pronged solution: a Head DS, which is short for Another Hearing Aid Scenes Dataset, is a dataset designed specifically for scene recognition of audiologically relevant environments, and YAMNet Plus, a sound recognition model optimized for edge devices. Both dataset and machine learning model are fully open source. On to our dataset. A Head DS was derived from two existing open source sound datasets, HearDS and Chime6. HearDS provided background environment recordings. Chime6 was used for speech samples. We mixed these two datasets together to form a Head DS. A Head DS comprises 9,968 audio clips, each 10 seconds long, recorded as single-channel 16-bit integers at a 16 kHz sampling rate. A feature of a Head DS is that speech and environment sounds are pre-mixed and the dataset is divided into a 70-10-20 split for training, validation, and testing respectively. The reason to pre-mix and split the data is to have consistent testing data. It is difficult to reproduce and compare results when testing machine learning models when data is mixed and divided on the fly. We hope the open source nature and standardized dataset drive significant advancements in scene recognition, much like how standardized image datasets have done in computer vision. Moving on to our sound recognition model, this slide illustrates the architecture of YAMNet Plus. YAMNet Plus is an enhanced, fully open source re-implementation of the original YAMNet model. While the original YAMNet provided model definitions and weights, it lacked crucial components like training code. We have addressed this by creating a complete workflow for YAMNet Plus, including training code, testing code, and conversion tools to convert the model into a format for edge deployment. YAMNet Plus takes an audio waveform as input, from which a log-mel spectrogram is computed. This spectrogram is then treated as an image and processed using a mobile net architecture. YAMNet Plus is able to load weights created by the original YAMNet. We use transfer learning to improve classification accuracy. YAMNet Plus initializes weights trained on the large audio set dataset. The model file of YAMNet Plus is only 6.2 megabytes and suitable for low-powered edge devices. Here are some performance metrics from YAMNet Plus. We benchmarked against the Head DS testing set. We achieved a mean average precision of 0.83 and an accuracy of 0.93. We sometimes find speech in music is misidentified as music. This occurs during pauses in speech and only music could be heard. We sometimes find speech in vehicle misidentified as speech in wind turbulence because the sound of rushing air entering the vehicle can often be heard. Overall results are very positive. We demonstrated real-time sound-based scene recognition by deploying YAMNet Plus to an Android smartphone. We wrote a test application which records some audio and processes it using YAMNet Plus. Our model takes approximately 50 milliseconds to load into memory and then processes each second of audio in approximately 30 milliseconds. Our tests were performed on a Google Pixel 3, a device with modest specifications released in 2018. We expect newer devices to have lower latency and take less processing time. This study successfully addresses key challenges in scene recognition for hearing aids by introducing a refined dataset and a highly optimized machine learning model. YAMNet Plus is a robust and efficient sound recognition model for edge devices like smartphones which operate in tandem with hearing devices. Ahead DS provides a dataset which forms as a benchmark dataset for scene recognition. Our code and data are both open source and are available at these links. Thank you.